My talk is in substitute for, it's in printed proceedings. You know, there is this talk by my good colleague from the United States, Bob Nugent. He is working with very serious projects on underwater robots, on fuel cells, and he is currently in very delicate stage, a very, very powerful project, and he was not, he could not be allowed just to come here present it. He was, so I apologize for him, but if anybody gets interested, I think it's in public, in proceedings, his work, so you can connect him directly. It's B. Nugent at Guardian6.com, its company. And he will be very happy just to make contact with you, or you just can contact me. We are in just frequent communication with him. So it's very, very interesting thing, because underwater robots are becoming more and more of interest also for civil and defense application. And the main problem is batteries. Batteries, traditional electric batteries, just don't allow just to go to deep waters, and so they're just looking for something like fuel cells and so on. So it's a future. It's a future. And it's one of the main problems. Another problem is communication, because underwater communications, they were restricted. And I'm not directly working with this, but I was just some papers on communication on underwater robots with limited communication, because I have some high-level ideology and technology which can robots be intelligent and make very much shorter communications for solving very, very complex problems. So in some sense, I have some relations with the topic, but it's not my field, fuel cells, and just here's his abstract, and he would be very happy. And again, apology for him, from him, because so my topic is this. Couple words about myself. So I'm currently representing Ukrainian Academy of Sciences, but I worked more than 16 years in different countries, total 7. So I was research professor already here in the United Kingdom, invented some distributed control technology. I simulated battlefields in some sense for DRA. I had special interest group in Florida. I was steering committee member of the biggest world project on distributed interactive simulation. In Germany, I worked for more than 5 years. I was twice Alexander von Humboldt Fellow, and I worked for Siemens Nixdorf, chairing distributed intelligent management of computer networks. I also worked in Czechoslovakia. I was deputy director of Artificial Intelligence Laboratory, and in the past, I participated in creation first computer networks from 1969. It was well before internet, and we distributed algorithms. So mobile code, mobile agents appeared behind Iron Curtain from 1970, 71, 20 years before they were patented in the United States, so everything. And my institute is part of huge cybernetic center. In its infancy, it created first fully universal computer. It was 1 mile from my house. You can find it in Wikipedia, not including UK, but it was much more universal than Konrad Zuse computer in Germany, because it combined program and data in one memory. It was implemented, and so it's just heritage. And my institute was researching. It was 8,000 highly qualified employees. It researched in many areas, also in special languages for communication with other civilizations. There are big PhDs for this topic. It was well funded, and after collapse of the Soviet Union, so the situation is not very good, and so. But there are still people working, clever people working in different fields. So this is, and what would I tell? There are some word about 21st century challenges, geographic and human terrain. This new topic appeared, very interesting, for the last few years, called human terrain. Human terrain appeared, everything appeared first in military, like DARPA, ARPA, Internet, and so also human terrain. Human terrain, it's you may solve complex problems instead of battlefields with using weapons, just by working with societies, investigating societies. It's a very prominent field. Possibly, hopefully, it can reduce bloodshed and just and reduce loss of lives and wealth and so on. Very, very interesting topic. There is growing publications this topic, and actually in this environment, I'm just first time presenting this topic. Then spatial grasp model and technology. So for many years, for 45 years, I'm working with dynamic networks, organizing them, working something, solving together. So I have technology like a virus. I describe some semantics on top level, inject into distributed system. It spreads, creates spatial infrastructure, and I'm keeping distributed network systems just in iron fist, as to say, ordering them to pursue common global goals. So this I will be telling something. Then I will show how can this be used to express some human terrain operations. Name other applications, conclusions, and references. And unfortunately, I have very few time, just like for 40 minutes, maybe 35 minutes with questions. Material was oriented on separate workshops, about 4 or 5 hours workshops. So I have about 85 slides. So I will show just basics and show you slides. I was not prepared for this presentation. I'm substitute, so I did not measure time, something like so. If somebody gets interested, so I will send these slides, or can make references for communicate or other publications, or organize any communications if you like. If not, just so you may ask questions during my presentations. If you're not interested, something is of interest, something is wrong, could you please tell something? So, among 21st century challenges, this is written. I would be very happy if you read this all, or at least I will read something. These numerous challenges include ethnic and religious conflicts, failed states, global terrorism, WMD proliferation, cyber attacks, climate change, and transnational crime, which can result in direct threats to national and international security. And the location of these threats is moving. So you see, this century is very dynamic, very, very dynamic, and actually nobody knows which the whole world will go, even in the nearest future. Other threats, it's employment insecurity, growing inequality, periods of macroeconomic instability, food shortages and hunger, where about 850 million people in the world are undernourished. There's lots of challenges. And many of these numerous challenges can lead to increase of national and international tensions, which are still being resolved, or at least attempted to, by the use of military force. You will see the military force is used everywhere. And this is becoming enormously and increasingly dangerous, because the world has accumulated huge amount of weapons, especially nuclear weapons, and any just discharge, any inaccuracy, even unintentionally, accidentally, can trigger very, 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 very bad things. And as you know, the whole world can be destroyed without 20, 30 minutes and 400 times. That's the world we live in. So using military forces, military means to solve conflicts is becoming more and more dangerous. So I participated in a number of military-oriented conferences. I had 2 workshops on missile defense using this technology. I'm not a military person, but I was invited just as a system scientist to assess stability of the world and so. So it's very, 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 very dangerous. And taking this into account, so we must, as much as can, find and use quite different and much safer means and efficient means for resolving numerous conflicts and problems. And these may include diplomatic, economic, social, cultural measures rather than weapons. This paper, this presentation relates to a very new but currently rapidly developing trend called human terrain, which is based on analyzing complex problems in human society through the anthropological, cultural, ethnic, political, and communicational dimensions, with subsequent finding effective mechanisms for resolving crisis by non-military means. Especially in the United States, when this topic is being developed very quickly in the Washington, D.C. area, there are a number of companies working in human terrain. It promises many things, because you can reduce even military spending by millions, because you can solve problems just by negotiation, by solving some conflicts, by using study detailed study of societies with what you want to conflict. In our case, what I'm doing, I try to extend this topic, not taking it from military dimension, same like internet appeared from DARPA, from DARPANet, to solving greater problem, especially I'm currently from Ukraine, and everybody knows how dynamic situation there is, and lots of bloodshed could be spared, could not be if such things like human terrain techniques could be used in a much broader scale. It's only beginning, but we hope that can do something useful in this way. And the paper offers special high-level networking ideology and technology, already having many research applications in distributed network systems of different orientation and in different countries. I saw in Germany it was used for management, high-level management of computer networks. In Japan, I wrote a research for cooperative behavior of robots using this. In the UK, my team simulated dynamic battlefields on multiple computers, and this was part of great distributed interactive simulation project from the United States. It was branch, and I launched special interest group on mobile technologies, which was operational for 3 years in Florida, in Orlando, Florida. So, geographic and human terrain. The term terrain. Term terrain is used in geographical dimension, just it's referring to lay of the land. This is usually expressed in terms of elevation, slope, and orientation of terrain features. You see some pictures taken from internet. You have impression what geographical terrain means. Human terrain deals with people, relations between people, history, culture, religions, and so on. Human terrain is working with population, its culture in interaction. This is new term, very new term. Not always it was accepted very well. For instance, anthropologists became very angry because some military is using anthropology to investigate societies in which you can solve some military-oriented problems. So there's huge row of anthropologists, but term survived, and we picked it up, and we tried to use it in much broader scale. Term is very good, and we are using it. There is even a special joint doctrine in the United Kingdom called GDN 4/13, Culture and Human Terrain. It's part of the military doctrine. You can read it directly on the internet, and it's written importance of cultural investigation of different societies for solving problems in this. So military picked it up in hope that it can solve something, but topic is much broader than this in our opinion, in our research we now started. And culture defined as a customs, ideas, social behaviors within the GDN 4/13 definition, or particularly people or group. In essence, it is a shared concept that guides what people believe and how they behave. It includes how they organize their beliefs and values and the ways in which they interact with each other outsiders. Human geography is defined as a branch of geography concerned with how human activity affects or is influenced by the Earth's surface. It includes themes such as ethnicity, demographics, language, religion, education, medicine, land use and ownership, and transportation. This data is used to enhance understanding and inform intelligence collection and analysis. It's not pure intelligence. It's much broader than just intelligence which is used under this term of intelligence. And human terrain is defined as characterizing cultural, anthropological, ethnographic information about the human population and interactions within the joint operational area. Operational area still stems from military definition. Human terrain analysis is the process through which understanding of the human terrain is developed. It integrates human geography and cultural information. This may be just some very dense definition of what human terrain means. And human terrain research areas on publications, and we also try to understand what will be most important. This include, I will not read these definitions, anthropology, sociology, political science, psychology, linguistic, religion, memetics. If anybody knows what memetics mean, it's also very new discipline. It's appeared in Oxford University. One professor, Dawkins, I think, says that memetics is like genetics, but just information structures which can self-replicate, evolve, can shape society. So it's just trying to copy genetics in information scale. This topic will be very nice for such kind of conferences, because memetics is information equivalent of genetics. For science information conference, it will be of great interest. In the United States, it's also appeared discipline called military memetics. I know people who are working in this area and communicate with them sometimes. How can you represent human terrain? I showed you representation of physical terrain, some pictures. Human terrain may be represented as persons and relations between them. So it may be structured. Instead of person, maybe a group of people. It can communicate, has relations with other groups, with race of individuals. So human terrain is huge, distributed, interconnected network, which may have both virtual dimensions. It may be virtual links between virtual addresses via internet, or maybe also physical addresses of persons who just participate here. Also physical links, some between them which are linked on distances, something like. So it's just a mixture of physical and virtual dimensions within this representation. And most human terrain problems can be formulated and are being formulated on such representation of human terrain. And it's very complex to prepare. Maybe some similarity with weather prediction, because humans are moving, relations being changed, and to solve something in these dynamic networks, you need very sophisticated dynamic technologies which can do something. Because if you collect something, then people have moved somewhere, so it may be value of this may be nothing. So we are working with such, as I told, with such technology and network. It's like a virus. We can inject some high-level vision or scenario. It spreads between computers. It creates dynamic infrastructures. It's much different from traditional multi-agent or interoperability measures. They have things, they have communication, and they try to receive the whole. We try to grasp this whole in some higher level vision, and I will be speaking about this, which is based on gestalt psychology rather than communicating agents. I don't know how many people are aware of this philosophy in psychology. It appeared the beginning of last century in Germany. It was first strong challenge to atomistic vision of the world. Gestaltists declare that human brain is capable to grasping the whole, grasping semantics, and human brain then makes inference of different parts starting from the whole. Science, analytical, so they start from pieces. They communicate these pieces. They establish languages of communication between pieces, and they want to receive the whole, and they don't get this whole because they started from different sides. Of course, there is a two-side movement, but Gestalt psychology was very powerful. Unfortunately, main philosophers of Gestalt psychology fled to the United States before the war, because the Nazis grown. Many of them were Jewish nationality, and so. But this I've been 4 years in Gestalt Congress in Germany. I made presentation of this technology, was well accepted. People mostly use this technology and psychology in medicine to create strong person, not split into pieces, integral person. In the United States, there's some work to create integral soldier using this. What we are doing, what I'm personally doing, is trying to use this spatial grasp to coordinate large distributed dynamic systems, just to cultivate this kind of vision. and especially which is needed on solving some problems in human societies, because lots of dangers. You see, there is some Dalmatian dog, and so you understand that this is dog. There is some trees. It's very difficult just to recognize it by anything. But human brain works. It's a very famous picture from Gestalt psychologists. Another pictures you see. You see some shapes, but they just it's your imagination. They're not there. It's imagination, and you see. And that's a problem because in many cases, many politicians fail just to understand things. They have this spatial grasp, don't have this. But philosophy is very good. It's still being reborn, and being developed. I have some funny pictures. I did it myself. Some figures I painted in oil in the past and tried to create things from metal for some ideas. This is called Mona Lisa or Gioconda. This is soccer player. This is thinker. It went done within 15 minutes, but you have some impression, grasp, and you just do things. There are some other things, so I have many such things had in the past, but I'm not engaged in doing this. And history of this technology. It has rather long history. So I was making first computer networks. First, I was a power network engineer, simulated distributed power networks. I was in the team that created first computer networks from '69. I was engaged in parallel computation. So you see this huge list of the use of distributed networks, dynamic networks, for simulation of different systems. There is a European patent. It's old now. I'm preparing a new patent. 2 John Wiley books I'm creating now, finishing now in the 3rd book for Springer. And there's just history and that was about more than 40 years. Soon be 50 years engagement with distributed systems. So there are some experience which may be of interest. How you solve these problems in this? You have vision of some system. You navigate mentally the system. You have feedback. And you are not keeping agents. If people say that the agents are main model of artificial, it's completely wrong. You do not have agents in your brain. You have vision. You have fields. Agents, it's very artificial. And lots of software now still are based on the philosophy of agents. How does it work? You have interpreters of this technology. It's embedded into different resources, and it's very intelligent, highly intelligent. They can communicate, but its system is amorphous. You describe semantics, what this system should do, on some high-level mission language. You inject this semantics, it becomes spread like a virus, creates infrastructures, and you, in some sense, put a soul in the distributed system. I had very hot clashes with Marvin Minsky, one of big fathers of artificial intelligence in the United States. His book, Society of Mind, is based that there are very simple agents. They communicate with each other. Somehow there appears intelligence. I asked him how this intelligence appears. He did not answer me because it's natural process, something like appears. But I start from quite different sides. I make intelligent agents, but I put into them some higher level scenario, making them organized. So it's combination of distributed agent system, amorphous system, and I'm polarizing this system, injecting high level semantic scenario, which is working in this system. This is the game which I was doing just three decades in distributed networks, and it works. It works. When you spread your intelligence, you dynamically may create infrastructures between different nodes of a network. You may inject different scenarios which can compete. So this is like distributed computer which is working with many programs. You can inject different things, semantics, what you want to do, and this semantics creates some structures. But I say it's There are lots of software written, there are a number of implementations, so you should believe so. After 45 years of doing such things in distributed dynamic networks, there is some vision which can be used for solving problems like for problems for human terrain. Some general issues, so I have not much time, have lots of applications. So in this technology, you can directly move through, observe any decisions in space, just like you think. I go to this shop, want to buy something, no, not something, I go somewhere else. If I find something, I tell my friend, friends, he or she will go from this shop further. So you describe what you think about space in this language. And many tasks may be formulated in such grasp or vision of distributed spaces. Any sequential or parallel centralized distributed algorithm can be expressed. So I created distributed Petri nets, distributed knowledge bases. We made simulation of some maze propagation. Space was distributed between different computers, between different countries, and all the space worked like one computer, but everything was distributed. But we have program. It's not just we are waiting, this became some accidentally doing something together. We had strong coordination because some higher level vision with ignoring details which were inferred automatically allowed us to do things. And this formalism, you can work with virtual world, physical world, executive world. You are describing some formulas like in traditional languages, but the same complexity of moving some in physical space, doing something in parallel, doing something in virtual space, or coordinating something. You describe a very simple program, which is 100 times shorter than in Java or something like this, but it works in combined physical virtual environment, and I will show something. This is general recursive structure of the language. A language may be just constant, maybe information, meta, customer, grasp, maybe variable. There are also global variables, heritable, frontal, environmental. Some variables can move in space, some can be inherited, some can be attached to common resources. And you have a bunch of different kinds of variables and some navigation code, and you create some highly parallel dynamic distributed algorithm. And the rule can be everything: movement, creation, echoing, verification, assignment, advance, and so on, so on. So if somebody gets interested, I can send you some papers or just the slides. There are about 170 publications on this approach. Maybe the last most important was that 70, 80, something like this. And some elementary examples. If you want to assign to the variable result some sum of variables, you write this. Or you can write also traditional notation. If you want to move in parallel to physical location, x1, y3, x5, y8, you write this. If you want to create virtual nodes somewhere in the internet or somewhere, you create node. If you want to extend knowledge network with some links, Peter is father of Alex. So you say different kinds you can combine in one thing. You do not need different languages. You combine things because you have integral space, and you just, like you think, you're working in this space. It's just based on rather on some integral, holistic Gestalt-like perception. Of course, it's a general theory of Gestalt, a general philosophy, but we are using it very, very effectively. Interpreted, there is some structure of interpreter. Interpreter can communicate with other interpreters. They may be hidden, maybe 1,000 millions hidden. They may be concealed if you're working with hostile environments. This is a machine. Different interpreters have incoming, outgoing queue. You inject some distributed scenarios, and you have parallel computer with variable topology, without central resources, but within this model. I create hierarchies if I need. They've been changed immediately in space. So I create everything dynamically in fully amorphous, initially distributed spaces. There are some, also, it's not so cheap. During spreading different things, I create some sort of command and control structures which are being distributed. They keep variables. They allow further navigation of things. That lots of very powerful things, but they 90% hidden inside implementation of this technology, which I usually have to be written explicitly. So this technology is based on powerful internal distributed parallel machine with 5 types of different messages, with control messages, and so very powerful keychain. In military, such things called command and control. So this command and control, by throwing semantics on systems, appears automatically, and the system is working. There are some different kind of variables. And I'll show some exemplary human terrain operations. I want to tell you that it was great interest for this technology in 1990s. In the United States, I was working in Germany. In the United States, I was an enthusiast from Lockheed Martin. He was making bombs. He became mad. And we created some sort of startup company in Silicon Valley near Sunnyvale. It was so new at that time, and I was not a US citizen, so so the company just existed a couple of years. It was very new, but it was well accepted even at that time. But now in our dynamic world, the special and dynamic battlefields, a dynamic reaction on crisis situations. So just the time, and we are using this technology. Imagine there is distributed knowledge network representing individuals, different relations between some. There is no central resource. This can be distributed. It can be different mobile phone. It can be different computers. It can be different whatever you want. They have links. Links can be supported by exchanges. You write to count number of nodes or count number of links starting from any point. This is very simple. I will send you just the code. I can explain to full details how everything works without any central resources. You want to find node with maximum number of links, indication as a possible leader. If you want to do something with human terrain and say, you try to find leader who may be a good leader, a bad leader, you want to do something like, you write code like this. Codes are very, 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 very short and very powerful. You want to find all paths between nodes, say 1 node, first node, and 6. There's all passes here. Why you need it? You need to assess some person through relations by other persons. And you will write this, and you will receive all paths between this. That's all you write. That's all you write. All paths between nodes via certain links. You may, if you wire certain links, you may reduce number of results. Any single path, that's all paths, and this only one single path being either this or this. It only gives. It's much cheaper. It creates any single path between 2 nodes. Any single path via given links. Single pass with collection of links which are passed right in this. Shortest path 3 from node 1 covering all nodes. It's not so simple problem. If you write some classical description, so if you put agents in different, if you want to create shortest path 3, it's lots of things. It will be 100 times longer program that I have written this program. Everything is hidden inside. I'm writing just what you think. I go from here to some node. If I come something with shorter distance from the start, I redefine distance, redefine predecessor. I go further. And all this process, not looping, it terminates. It terminates, and you create, within this short description, shortest path 3 covering all other nodes. If you find dissertations, or if you find the publications, there are lots of things of finding shortest path 3 in distributed environments. It's very complex problem. In this case, so it just reflects your grasp or gestalt you have in your brain to solve this problem directly. It was shown many years ago in distributed environments. If you want to find shortest path using this created, so you just trace from final node to the root or through the shortest path 3 which created. This is this. If you want to combine finding shortest path 3 and shortest path, there are different variants of combination. This is more intense computational time. For instance, finding the node from which shortest path 3 has lowest level. So it may be a real some leader of some good or bad leader in some distributed human terrain, because It has the shortest, longest distance from this person to others. And find the weakest or articulation points. These points in the graph are very, very dangerous because if you remove them, you just split graph into pieces. It's no, that's the weakest point of the graph. This is program which written finds in all articulation points, and it can start from any node of the graph. All the graph is becoming solving this on itself, and these articulation points just announced that they are. If you want to strengthen graph, so you can add some links like here. You can strengthen graph of this, so you're writing this. Find the strongest subnetworks or cliques. Everybody knows most powerful things when every node has connection with everybody. These groups are maximum on the number of nodes. There are four such cliques, but I have shown only here. There are one more. They're all triangles, but they can be any others. Program finding all cliques in fully distributed environment, started from any node, is writing like this. So all the network is very well scaled. You may be distributed worldwide, and you can find all cliques in distributed networks. So that is very, very powerful thing. So you can either trust them, or you can just remove any clique, and you can weaken the node. Finding arbitrary structure. Imagine there is knowledge network distributed worldwide, and there is some pattern which you want to find. This was part of a project in Germany when I was working on Siemens project for finding hackers in distributed networks. So hacker was found here, had some links, and there is some collection of some logical things about hackers. Usually at that time it was solved many things on top level about humans which were communicated. So in this case, you can describe any pattern. It can be fuzzy, it can have alternatives, and you can throw this pattern, started from any node on this network, and all inclusions of the pattern can be found. Here are different possibilities, using paths via all links of this pattern, or using paths via all nodes. There is lots of other possibilities. There are some delicate things, and you can find solutions. Find arbitrary structures with certain link given, with links as variables, different solutions. Other possibilities. Imagine you have physical dimension also of this network. For instance, nodes have physical addresses, and so you want to find some weight center, physical center of this network. You write the code like here, links accounted, links not accounted. You want to find some distance, say, between different physical centers of different groupings of people. Say people of our religion, or just beliefs, people of other beliefs, and just to measure distance between physical centers. If the distance is very short, it may be spark clashes and something like this. It's only example, but it may have many more variables and many more things. For instance, they become after movement, a random movement, very close, and you can regular check, or can put all the system in simulation mode. So we allowed units may randomly, and then check in distance, something like this. Other things, other examples. Imagine you have some zones of hostile activities, maybe foreign fires, and maybe robots began moving towards these regions, circling them, and you have impact. So all this written in the code like this. You have distributed systems with sensors, say through the city. It was a topic discussed in Japan, because some elderly people often get lost, and how they trace them. So the system can use some spatial intelligence, which is moving and tracing people, keeping with them, and if they disappear somewhere, it begins searching the region around, finds them, and something like. So you cannot lose this person with this spatial grass which are moving with this person. It may be in parallel with many things. Maybe other applications, also for military, for missile defense or something like so. So it's many applications. So it's just technology. Or just if you have some disaster zone, you can organize guys here in a row, and you can use only the first nodes, waypoints, others just following each other, and there's just collective behavior with one following each other. Everything in parallel. So you distribute, so automatically program is being distributed between participants, and they are just working together, going out of this. Emergency management, if there are some symbolic, wreckage of system after earthquake or something, if you have interpreters installed you in different points, and you can start from any point. If there is any communication, even voice communication, or even communication, visual, tactile communication, you can organize the system just doing something, collecting number of casualties and just distribution of relief delivery or something like that. So other human terrain related to today's presentation being investigated. It's runtime trends in analyzing moving individuals, inferencing adversaries' intent during conflicts, investigating critical infrastructures and key resources, providing global situation awareness, social network dynamic simulation and analysis, classifying, discovering terrorist suspects, organizations. Also, definition of terrorism, that's very, 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 very delicate, and I'm not just trying to go to conclusions here. Investigating, blocking spread of harmful ideas leading to massive violence and crime as related to memetics. Investigating ethical, cultural, religious origins of conflicts, human terrain, world dynamics of the 21st century, using vast unmanned system for collecting smart data. There's lots of such things are being investigated. There are some fragments being programmed in this technology, and in hope that we will find good customers who just make massive support. Other applications. Technology was used in different countries, as I said, and there is interest also for it from defense applications. I will show some defense applications. It's civil conference. I'm civil guy. I'm not working for military. But if you are invited to some military conference, and if you survive between decorated people who say that means something, you say have something. It's a great pleasure. It's great pleasure. So I did it for about 15 times for the last 3 years, about 20 times for formalizing command intent and command and control. You are just peaceful people, but for international forces, one of the problems is people speak in different languages, have different documents and so on. So task is to formalize in such a way that it should be clear for everybody, like for computers. Also, it can be computerized. It can be put into robots, something like this. It's top-level robotics, because many people work as low-level. Robotics can be robotics real if it fits command and control structures in societies. There are some simple, very simple. There are some lines. There are some objectives in space. There are two friendly your units. There are different adversary units. You want to move from here to here, destroy something on your way. I think it's just computer game. And in traditional languages, formalization language is called battle management language. It's used in NATO, and so they write, for instance, commands for one unit, commands for another unit, which can communicate, and so it's terribly. So formalization is becoming much more complex than just you write in traditional human language. So all this task is written in language which I am developing is this. You just write semantic, what to move, what to do, not making all these tedious things. And if something changes, you can easily change this scenario. It's maybe not only for military, it's crisis management, it's economy management, something like this. Just only very, very extreme applications. If you are not mentioning own forces, not mentioning adversaries' forces, saying main stages, so different possibilities, or just writing so-called command intent, what you want to achieve. Everything can be written with this language, working in space, with space and conquering space. So you can have huge range of things within the same formalism, from detailed tasking and collective robotics. So installing interpreter of this technology in different robots, you can organize different scenarios of them working together. you can describe these scenarios on very high level, like here. Go to physical location of the disaster zone with some coordinates looking here, evaluate damage in each location, and return the maximum damage value. That's what you write in this level. So it's shorter than in English. Traditionally, maximum, move, and so. How does it work? You have distributed space, you have 3 locations, you have scattered robots. You can inject this to any robot. Robot became partitioning this, sending it to different robots. They establish command and control infrastructure, everything dynamically. So user is not involved in this. Robots became moving in parallel. They return, can find maximum damage, and this is returned to some center. You see, this is semantic level description. In formal presentation, and all the group of robots, this dynamic group, is becoming parallel computer working in space with a program which is just injected through any of them. This is a very powerful result, because you do not know how many robots are. If some of them fail, it may be redefined and everything. So you have dynamic environment. You do not know how many participants, but you know what you want to do. You throw your intent, written in very powerful, fully formal presentation, and the system is becoming self-organized and doing things. Some more detailed. Imagine that you want to organize a swarm movement of robots. Each robots are moving some randomly through the vector somewhere. But you also want to establish some dynamic command and control, because they should be coordinated and so. So they individually, without any external help, find some central point. From central points, they create runtime infrastructure. These infrastructures are collecting things like targets. And if they move, all this is being redefined. Center is redefined, infrastructure is redefined, because if they move randomly, you need some keeping main robot, something in between, something in weighted position. All this can be written, all tasks can be written like this. And in the end, this task written in form, you can combine them in one program, combining loose swarm movement with strictest hierarchical control, and you have both things: flexibility and strong control, and dynamics and plasticity, because everything is being changed in time during other applications. Finding all viruses in parallel. In networks, you can navigate. This is one of the projects in Germany. I was how to find virus sources using a sort of antivirus mobile also as being itself as a virus technology, which is just doing something. There are some different problems. Army side defense, European scenarios. Just if you know, there are some different European scenarios how to respond on different threats and so. And all the scenarios can be described within coordination of this. This is very powerful thing, which needs hundreds of pages usually, and can be described just semantics of control. Advantage is the following: if something damages, if something happens, this is fully interpreted code. It's like a virus. It can recover, self-replicate, recover, and so you have some live control system which is distributed in between, and it can survive even with different units can be damaged. We live in very dangerous world. I was told that I was leading 2 workshops on distributed missile control and something like it's. As a scientist, I'm not a military person. And there are some already printed lots of different possibilities of world scenarios. I'm not just describing in detail these, but such different scenarios which may happen unexpectedly in the world can be in principle extinguish something with such dynamic distributed technology which can do it. So we hope this, and there is interest of this. I didn't go because situation in Ukraine. I have very honorable presentation in Germany on missile defense conference 2 months ago. I didn't go because situation in Ukraine. But it's big interest of this technology. But I say that this presentation is not military. It's just how to analyzed human system, human terrain, how to investigate problems, how to find points in which you can press something like can just strengthen or weaken or something like. It's very, of course, there are somebody who should do it, because sometimes politicians are not very much interested in such things. There should be scientists. Scientists should be in control, something like. I hope that if scientists could use such things, so many things in the world could be much better. Some publications, there are many human terrain publications, I just listed this. There are fresh journal papers, my papers on this. There are 2 John Wiley books and three chapters in other books. There are some more publications, and thank you. And this material is not in these proceedings because I am substitute, but I received a very urgent call from International Journal, Journal of International Relations in Diplomacy. It should appear in September. So if anybody interested, I can communicate. And it's only part of this material, but not badly written, and looks like they got interested that something can be solved diplomatically, politically, and not with weapons. Thank you very much. Any questions? Yes, please.
I'm just asking about the SGL. When you calculate the shortest path, does it just consider the number of hops?
Yes.
Or can it consider the physical distance between
Yes.
hops?
Yes.
Okay.
Yes. But it's hops in virtual spaces. You know, some persons may share some computer or something like, but hops may be in virtual environment. But if they go through boundary of computers, they can go physically there. So it depends how virtual nodes are connected to physical equipment. If you're sitting in some office. Office has communication with other things. So inside office, it can be a movement between you, and then you can physical movement. So, yeah, but you can describe some movement, and not only it's movement between computers. It may inspire movement of physical movement of units just to do things. So this is just combined paradigm. Movement in virtual and physical spaces. Movement in physical spaces may be physical. If you do not have sensors there, so sensors must move there. If you say, I want to do that. If there are sensors, and this XY position, so you can just jump there electronically and find something. It depends. Lots of possibilities. But what is structure is appeared. So this command and control, it's links called the track structure. It has different variables. Variables are moving. Command signals are going back. There is powerful machine which collects different message, different control states, and so, but everything is hidden. You may write it explicitly. Not everything you can describe. You can write something on top and say, in this case, I must detail. So you write just in program what you want. So this, I showed you different solutions, from top semantics to just to absolutely how to put a nail into wall. So, you know. But everything is in the same syntax. So you move further, you did something. You have logic. If I did this good, I can go there. If I'm wrong, I can stop. I can, if it's crisis, I can stop the part of a program which made some emergency. It's lots of possibilities. Well, I can show you. There are some constructs of language. I didn't think it's maybe of interest because a substitute. I just was planning just to make some short substitute of this. Thanks. No more. Okay. Thanks. Thanks very much.